So welcome back to example 4, where we're looking for the inverse trig functions of quadrantal angles. So the arc cosine of -1 is asking for the angle with one revolution around the circle that has an x-coordinate of -1. And the coordinate along the negative x-axis here is -1, 0. And that is at 180 degrees. And that's the only place where the x is -1 on the unit circle in one revolution. Okay, the arctangent of 0, remember tangent is the ratio of the sine over the cosine, which is the y divided by the x. So if I'm starting here at 0, that coordinate is 1, 0. And 0 divided by 1 is 0. So 0 radians would be our first solution. However, over here at pi, the coordinate is -1, 0. And 0 divided by -1 is also 0. So pi would be another solution. Then it says over the interval 0 to 2 pi inclusive, and when we cycle back to 2 pi, we're back at the coordinate 1, 0. So 2 pi would be another solution where the arctangent of 0 can be evaluated. Then in problem C, the arc sine of 1 in radians. So sine is the y coordinate, so we're looking for the angles that have a y coordinate of 1. And that would be up here at 90 degrees or pi over 2 radians. And that brings us to our secret question for this lesson. In problem 1, you want to evaluate the arc cosine of -√3/2 in radians. Problem 2, you're evaluating arc sine of √2/2 in degrees. And then in problem 3, you want to find the secant of theta when the tangent of theta equals √3 and theta is in quadrant 3. Make sure you show your work for these problems, and then you're going to upload this as the last page of your notes in Schoology.